In this lesson, we'll look at some properties of parallelograms. We start with a parallelogram. We know that the definition of a parallelogram is that it is a quadrilateral with both pairs of opposite sides parallel. So we mark those pairs of opposite sides as parallel. Then we draw one of the diagonals. We can do that because 2 points determine a line, so this is diagonal DB. And we notice that the diagonal is a transversal for both pairs of parallel sides. We mark in a pair of alternate interior angles relative to the left and right sides and the diagonal DB. And then we mark in another pair of alternate interior angles relative to the top and bottom sides and the transversal, which is diagonal DB. Now we have a pair of triangles that are congruent by ASA because they're triangles that share a side. That happens to be the blue diagonal DB. Then you can see each triangle has a red angle and a green angle and side DB, so that's ASA. And then, of course, by corresponding parts, we have that side AD is congruent to side BC, the left and the right, and AB is congruent to CD, the top and the bottom. And then we'll mark those. And what we've just proven is that the opposite sides of a parallelogram are congruent. And then also by corresponding parts, we get that angle A and angle C are congruent. And then we can draw the other diagonal. And now that we already know that the opposite sides are congruent, we have a new pair of triangles that are congruent by side, side, side. You can see the marked sides, and then remember, the third side is the side the two triangles share. That's side AC, the other diagonal. And then because those two triangles are congruent, we have that angle D and angle B are congruent also by corresponding parts. And what we've just proven now is that opposite angles of a parallelogram are congruent. So we started with just the definition of parallelogram, and from that definition, we've been able to prove that the opposite sides are congruent and the opposite angles are congruent, and we've marked those congruent parts. But wait, there's more. Now we have both diagonals marked at the same time with their intersection point labeled point E. And then we marked some alternate interior angles, and both of these pairs, the red pair and the blue pair, are relative to the top and the bottom. And from those pairs of alternate interior angles, we have a couple more congruent triangles by angle side angle. Triangle AEB, which is at the top of the parallelogram, and triangle CED, which is at the bottom of the parallelogram. And from that pair of congruent triangles, we have the parts of the diagonals that are congruent. A to E is congruent to C to E, and B to E is congruent to D to E. And after we mark those congruent parts, we can tell that E is the midpoint of both diagonals. And that means that what we've just proven is that the diagonals of a parallelogram bisect each other. And now we go back to our parallelogram, and we remember that if two lines are parallel, a pair of interior angles on the same side of the transversal are supplementary. So that means in this parallelogram, angle B is supplementary to angle C, angle C is supplementary to angle D is supplementary to angle A, and angle A is supplementary to angle B. And what that proves is that any pair of consecutive angles are supplementary. In this lesson, we started with the definition of a parallelogram, and we used that definition to prove several properties. Number one, from the definition, we know that opposite sides are parallel. Number two, opposite sides are congruent. Number three, opposite angles are congruent. Number four, the diagonals bisect each other. And number five, any pair of consecutive angles are supplementary.